There we go. Okay. So I'm going to give you guys a definition of a parabola. This is kind of more the geometry definition of a parabola as opposed to what you guys have studied with parabolas in the past, which was more the algebra way of looking at it. So like in algebra, you talked about a parabola being some kind of transformation of y equals x squared. Okay, so one variable was the square of the other, and then maybe you stretched it, shrunk it horizontally, vertically, shifted it left, right, up, down, or whatever. And parabolas. Every parabola is also a set of all points in a plane that are equidistant between a line and a point. Okay? So if I were to draw some line and some point in a plane, i.e. my piece of paper here, then the parabola that goes with those would be the collection of all points that are the same distance to the line as they are to the point. Okay? I'll show you. Okay, so this point right here. Okay, now just assuming that all the measurements are equidistant. Okay, I'm not going to take out my ruler and double checking every single one of these exactly, but do you see how that point is roughly in between the line and the point, halfway in between? So it is equidistant to the point and the line. Okay, now if I start to go a little above or a little below that point, okay, I have some more that are equidistant. So if I had another one that was maybe right here-ish. Okay, now remember from geometry, how to calculate a distance from a point to a line? Do we not remember that? It's perpendicular. Okay, so this distance and this distance should be the same. Okay, now moving this point up, do you see how I have to keep moving it over as well? So if I had another point like maybe, where would it be? About right here or something. So that point, the distance from the point and the line, I'd have to extend out a little bit. So those two distances would be about the same. This one we had this distance and this distance the same. And if I started putting points, kind of in between that had that same quality going on, and I did the same thing down here, see what I'm starting to make? It's making a parabola. Okay? Keeping all of those distances the same from the line to the point creates a collection of points that makes a parabola. So all those together is this parabola. Now this particular parabola happens to open to the right just because of the geometry of where I put the line and the point. But however I orient those, to see how I can make my parabola the direction I want. If I point on the left side of the line, my parabola would open left. If I had a horizontal line and the point were above it, the parabola would open up. If I had the horizontal line and the point below it, the parabola would open down. Okay? And I could even, put it at an angle if I wanted to. Okay? We're just going to stick with left, right, up, and down parabolas for now. Okay? In your function world, in algebra, you pretty much just stuck with parabolas that opened up and down, right? Because it was always x squared, those kind of parabolas. Okay? So what do you think is going to be the case for parabolas that open right and left? Y squared. Mm-hmm. Y equals x squared produces up and down. Equals y squared produces left and right parabolas. Okay? So we're going to investigate that a little bit as well. Okay. So on this picture, there are some special names for some of these different things that we've been talking about. So the point we were using to make our parabola has a special name. It's called a focus. And the line that we were using, that all these points were equidistant to, has a special name. It's called a directrix. So often this is referred to as the focus directrix definition of a parabola. So we're going to jot that down. So a parabola is a collection of points in a plane equidistant from a point, the focus, and a line, the directrix. Okay, and we'll probably won't get to this till tomorrow, but the focus is important too when we start talking application stuff. You guys have seen like satellite dishes and that sort of thing. Somebody has like satellite TV, they got the little dish sitting up there. What does every satellite dish have attached to it? You notice that it's got the dish, but then what's also attached to the dish? There's the little thing that comes out that then has a little thing that sticks out, right? Well, where do you think that's positioned relative to the dish? It's the focus. The dish is the parabola. That little thing that sticks out is the focus. Because every time you shoot a beam of anything, light, guess what happens? It bounces off and goes through the focus. So wherever this thing is coming from, it always goes through and hits, reflects off and goes through the focus no matter what. So it's not just a fancy name. It's called a focus. Because everything focuses there, right? Whatever you shoot at the parabola, everything's going to focus in on that spot. So that's why we have these big dishes, because it catches all of these signals, right? And then it takes all of those signals, no matter what angle they're coming from, and boom, puts them all in one place. So if you can construct perfect parabolic dish as you can focus whatever that thing can catch into one spot. That's how satellite TV works. You're screwed if any signal happens to bump off the dent. Yeah, you can catch every signal except for one that happens to make a bad shot at that little dent, and then you lose that signal. So, yeah, so that's why you see a lot of parabolic dishes on, for TV, and then there's a lot of satellites up in space that have big parabolic dishes attached to them and stuff because they're catching beams of information or whatever. So, shouldn't. I mean, if it's in the process of raining and it's like creating like a puddle on the dish and then stuff comes in and hits the puddle, then you're going to lose that. So sometimes when you have a satellite dish and it's bad weather out, you lose signal. That's why you lose signal, because it's not bouncing off the dish, it's bouncing off the water instead, and then it's not focusing where it's supposed to. But anyway, so equations of this stuff. Let's take a look at a particular parabola. One that's oriented in such a way that you guys are a little bit used to it. And we're going to put this on the XY plane here. So let's have a parabola that right off the origin. Okay, so this point right here has a name. You've talked about it before. What's it called? It's the origin, but on a parabola, what's it called? This is the vertex. The focus, remember, is not actually on the curve, right? The focus would be like somewhere up here.
Oh, yeah. Is there a way to calculate where the focus is?
Absolutely. Yep, we'll do that. I'll give you an equation of a parabola and ask you where the focus is. And I'll also ask you where the directrix is, just because. directrix is, yeah, this imaginary line that's like down here somewhere now. Somewhere. But it is. Now, because we have this thing nicely oriented up and down, there are some calculations or some we know because of the definition of a parabola. It says that every point on a parabola is equidistant from the focus to the directrix. And the vertex is one of those collection of points, right? So the vertex should be exactly halfway in between the focus and the directrix then. Okay? So, then, I'm going to call this in here P. So the coordinates of my focus are going to be 0, P. Let me zoom in on that a little bit because we're getting kind of small here. I'm going to have to, yep, okay, hold on. Good. Now, the directrix, it's a horizontal line. It's underneath the x-axis. If the distance to the focus is a distance of p, then the distance to the directrix also distance of p. What's the equation of that directrix? It's a line, though. So, what would be the equation of it? Yes. Because it's under the x-axis. Okay, because I put the vertex right on the x-axis, then it makes it so it has to be underneath. So it has to be negative p. Okay, so the focus is at 0, p, and again, p is whatever that distance is in between, right, for this particular one. So then that distance going down to the directrix is also p, so we got y equals negative p. So, to develop an equation here, here's how we can do this. Say we got some point parabola, call it xy, because we're keeping it generic. It could be any point on the parabola, okay? Just some xy on the parabola. Well, the definition of our parabola says that the distance between these 2 points, distance of this point down to the directrix, not drawn to scale, just so you know, okay? Doesn't look the same, but they should be. This distance and this distance are the same. Distance formula between points here, they should come out the same. They should be equal. Okay? So I've got 0p and xy. Okay? So let's find the distance between those two. So that's going to be the square root of y2 minus y1. So y minus p squared plus minus 0 squared. And that should be equal to this distance between xy and this point right here. So take a look at the geometry of how we set that up. What should be the coordinates of that point? Perfect. Good. It's got to be x for the x, right? Because it's straight down from that. And it's got to have a y value of negative p because it's sitting on that line. So this has coordinates x, negative p. So now I'm going to do another distance formula with these two. Okay, so this should be equal to the distance, which would be, let's see, y minus negative p, so y plus p squared plus minus x squared. And now we're going to simplify it. And when we're done, we're going to have an equation for a parabola that we're going to use. Okay? So, first, square root equals square root. What can I do? Cancel. Square both sides. That would get rid of those. X minus 0 squared is just x squared, right? We got y plus p squared. And x minus x squared, what's that? 0, so just that, right? Okay, and so I'm going to do a little bit of algebra now. I'm going to actually multiply these things out because there are terms that will cancel if I do that. Okay, so y minus p squared is y squared. That would be 2yp minus 2yp plus p squared plus x squared still. And then y plus p squared is y squared plus 2yp plus p squared. So I do a little foiling with both of those. And then there's still that little x squared floating around. Okay, anybody notice anything we can start to get rid of here? Yeah?
Yeah, you can cancel the y squareds and the p squareds.
Right, the y squareds and the p squareds will be gone.
And then just move the 2yp to the right side.
I'll do one step at a time here. So get rid of all those. Next, 2yp plus x squared equals 2yp. And then you said take this one and add it over to there. Yep, and just doing a little bit of rearranging. There it is. Now, we did not solve that for y because we're used to doing that, right? It's a parabola that opens up. It should be y equals something x squared. Why didn't you not do that? Our calculations are just going to be easier if we leave it this way. It avoids using fractions because that 4p would have to be divided then. What it does do now, though, is, as I know p, the distance that we're talking about between the vertex and the focus, which is also the distance from the vertex to the directrix, however wide that gap is, it sets up the whole equation for our parabola. Does that make sense? I mean, geometrically, we just said it's a collection of points the same distance from the point to the line. So as long as we have the point and the line, and we know how far apart they are, we should have a unique equation for that particular parabola, right? So if I give you some information about, like, where's the focus, where's the vertex, where's the directrix, which way is it opening, up, down, left, right, you can come up with an equation for it, okay? This is the equation for the open up parabola, okay? There are slight variations on this for the open down, open left, open right. I'm going to just jot all those down for you. I'm not going to go through this whole process all over again. And then, as long as I give you the correct information, we should be able to figure this out. Okay, what is the unique equation that goes with that parabola? Okay, so, one that we just did, this is the opens up. X squared equals 4py. If it opens down, maybe you anticipated this. It's just negative 4py. If it opens to the right, we talked about this, the left and right parabolas, then the x and the y, like the y is squared instead of the x. So it's y squared equals 4px, and then opening to the left, but you're able to tell what's going on now, right? Negative 4px. Now, for today, we're going to leave the vertex at the origin. Tomorrow, we're going to start shuffling these around, up, down, left, right, move it off the origin a little bit and see what the equation is using this, okay? But for now, assume the vertex is at the origin, okay? So I'm just going to make a little note of that. vertex at the origin. And let's see if we can do this. See if we can figure out, if I tell you where the vertex, focus, directrix are, what's the equation?
Wait, you have to tell us the vertexes versus the origin?
Oh, I guess not. I guess that's, yeah. Later on I will, but not right now. Yeah. The focus is at -3, 0. And yeah, vertex at origin. So what is the equation of the parabola? So pretty much we need to figure out two things. We need to figure out what's P, and we need to figure out which direction does it open, up, down, left, or right. With those two things in hand, we can pick the right one and plug in, and we got it. Okay? So just by looking at the fact that the focus is -3, 0, what's P? P is always positive. 3. Okay, so P is 3. Right? Can you visualize which way this thing should open if the focus is at -3, 0? Left. Now, if you can't, it's okay. Draw yourself a quick little sketch. I do it all the time. -0, that would mean the focus is over here. A parabola will always open around the focus, right? So if it has to open around the focus and the focus is over here, parabola is going to have to go this way. Okay, so it's an open left. We said P is equal to 3. So what's the equation then? You got it. Y squared equals -12x. So does that make sense? How we were able to do that? Knowing the vertex is at the origin, it's really just a minimum amount of information, right? As long as they give you either the vertex or either the focus or the directrix, it's enough information to do it. So let's do one more. Let's say the directrix equation is y equals 5. And again, vertex at origin. So what's the equation then? So y equals 5. So the directrix is up. It's horizontal, right? Which way is this parabola opening? Down. It opens away from the directrix, right? Around the focus, but away from the directrix. So it would look something... There's your directrix. It's going to look something like this. Okay. What's P? Okay. And it's an open-down parabola. So what should be the equation then? Careful. Not -21. Oh. Okay. It's like, how do you get 21? Yes, correct. -20y. Good. If you guys an equation of a parabola to start with, can you tell me where everything is then? Can you go backwards with this process then? Tell me which way it opens. Tell me where's the focus, where's the vertex. Well, I guess the vertex you already know. Where's the directrix, all that sort of thing. So, see if we can do that now. All right, so find the vertex, focus, and directrix of y squared equals 32x. So I'd like you to take a minute on your own. See if you can do it. If you need to sketch a picture of what it looks like, perfect. That's fine. The equation is made, yes. Mm-hmm. Yeah, we might have some time. We're doing okay. Kind of a little sneak preview of what they're going to look like if they're not. But yeah, this one definitely is. Mm-hmm. The coordinates of the vertex are going to be just stuck in there. Yeah. All right. Anybody need more time? Are we still working? Looks like we got a few people still going. Okay. I will wait then. Yeah. That's that one section I said we might skip, but we'll see if we have time. Yeah, you can do that.
Isn't it like when it opens up is right? Haven't we used that before and it's just square root of x?
Yes. Yep. Because if you were to solve it for y, you'd have to square root both sides, and then, yeah. Yeah, but you have to use plus or minus. The plus is the top half, the minus is the bottom half. Yep.
And then the other plus or minus is left and right side.
Mm-hmm. Okay, I'll do the easy one for you. Whew. Okay, 0, 0. Good. Focus. Well, let's start with this. I'll ask you this first. What direction does this open?
Right.
Opens to the right, because it's a y squared, it's positive, opens to the right. Okay, so, second question, what's p? 8. Good, because it's 4p, so that means it had to be 8. Okay, so if it opens to the right, p is 8. What's the coordinates of the focus? Anybody? 8, 0. Good. And then what is the equation of the directrix? X equals negative 8. Good. All right, so making sense? Both directions with this stuff? I think you guys are pretty good. All right, we got a little time here. In fact, we got a lot of time. Is that right?
Yeah, we have a half an hour.
My watch is totally not that at wow. Anyway, okay. So we got tons of time. Okay, so I'll show you how to move these around then. So about transformations of functions in general, though. Okay, so go off to the side here just a little bit and revisit some stuff. Doesn't relate to these functions that we're working with, but I just want to give you a review of translating things using functions. So let's say I had equals sin x. Okay. And let's say I want to move it up 3 and left 4. How would that equation change? When we did transformations of functions, how did we achieve that? Moving it up 3, left 4. Yeah.
And then sin x plus 4 in parentheses.
So it'd be sine of x plus 4, okay? And then plus 3. Nope, it is plus 3. Now, this is how, because with functions, you're always able to solve it for y, right? So it's always, instead of y, we wrote f of x. And then whatever we had done to x, the left-right movement, we did the opposite sign and substituted it in. Put that number in there. Down, we just did a whatever it is on the end, but without changing the sign. So why the heck did we change the sign here, but not here? Shouldn't you have the same thing to both? Aren't they both kind of, the same? One's not more important than the other or whatever. It's all about how we organized things when we wrote functions, okay? Consider this for a second. What if I didn't write it as a function? What if I just did y instead of that? Then by doing this, y equals sine of 4 plus 3. Substituted x with x plus 4. Do one little change here. What did I substitute y with? The opposite, right? So technically, you're substituting x with the opposite sign, and you're substituting y with the opposite sign. It's just the fact that we can solve it for y that the sign stays the same because we would add or subtract a thing over to the other side. Does that make sense? So you really are doing the same thing to both variables. It was just all in how we were writing it before, okay? So when we're translating things around on the coordinate plane with these guys, with these parabolas that we're looking at, think about is change the signs for both and make substitutions, and it works. Okay? So I'll give you a quick example of that. So if we were going to do, let's say the parabola, I don't know, y squared equals negative 16x. And I wanted to move this thing down 3 and to the right. Okay. Y is still up and down, still left and right, but we're going to make substitutions for each with opposite signs. So I'm going down 3. So what am I going to replace the y with then, technically, if I'm going down 3? Y, it's y plus 3 squared. I'm making a substitution, right? So it'd be y plus 3 squared. I'm going to move it to the right 5, so what am I going to replace the x with? Minus 5. What do I do to move these around? Okay. This new one that I just came up with, where's the vertex? 5, negative 3, right? So, if I give you a new vertex that is not 0, 0, you can still do this stuff. It's just think about moving it, right? The vertex essentially tells you how to move, right? You just have to change the signs on both of them to figure that out. So, or if you look at you have to change the sign, put it in the equation, I guess. So, and what I'm going to do is I'm going to do similar to the last question I gave you, where I give you an equation. I'm going to add the same stuff. Where's the focus? Where's the vertex? Where's the directrix? And think about how it's been moved. Okay? See if we can do that. So let's say we've got so let's look at this one. So we'll start with the easy one again, or the easier one. Where's my vertex? 2, negative 1. Now, in the coordinates of your focus and your directrix, now that it's been moved, those things are in relationship to that vertex. not 0, 0 anymore. Okay? So you can't just look at it and go, oh, I know P, so you have to think, okay, how far from the vertex I have P, right? That far? I have to go P. That's funny. Oh, that's being recorded too. Anyway, so you'd have to figure out that distance P, how far is that from the vertex, not from 0, 0 anymore then, okay? So it's really crucial to know, again, what direction does it open, up, down, left, or right, and you want to move that direction the appropriate way to figure out where those are at. So with these, I almost always draw a sketch of them because it's just more helpful for me. I'm a visual person. I think for most of you guys, that'll probably be helpful too, just so you can see what's going on. So my vertex was 2, negative 1. So 2, negative 1. So there's that. Okay, so this parabola, is it up, down, left, right? Which way are we going? It's an x squared. It's positive up, right? So it's going to look something sort of like this. Okay, and what's the value of P this time? 6, okay? All right, so the value of P is 6. To get to the focus, because the geometry of the way it's opening here, the orientation of it, I'd have to go up 6 from the vertex to get to that focus. To get to the directrix, I'd have to go down 6 from the vertex, right? So if I'm down at negative 1, before I reach that focus, what's going to be its coordinate over here? Okay, yeah, it's going to be 5. So 2, 5 is the focus. And then to get to my directrix, so where is that directrix sitting? Right, remember it's right? So negative 7 would be 6 away from that vertex. So the equation of that line is y equals negative 7. Okay? So, right? You just have to think, like I said, in terms of moving from that vertex. Where are you at then? Okay? So, these to try. I'll give you 2 more equations, and I think I'm going to wrap up with that. Call it good. So I'll give you 2 of these. The focus, vertex, directrix will be good. That'll still leave us with a decent amount of stuff to talk about tomorrow. So, well, we'll just make this like a 1 and a 2. All right, let's go with that one. Actually, we'll just go 4y on that one. All right, so see what you can do. Okay, guys. So just to review really quick, we were talking yesterday about equations of parabolas, and we came up with these four depending on which way it opened. Okay? So today what I'm going to do is I'm going to start by rewriting these four where the vertex is not at the origin, and then we'll have that list to go on as well. Yes? We'll talk about it later. Just let me get through this, and then we'll go back. It's, well, real quick, I guess. It's on the graph right here of a parabola. There's a vertex, there's a focus, and there's a directrix. And a parabola we defined yesterday as being a collection of all the points that are the same distance from this focus to the directrix. So pretend like these are the same length. So P is that distance from focus to vertex, which is also the same distance from vertex to directrix. So in making our equations, as long as we can figure out what that is, and usually you're given a focus and a vertex or something, so you can just measure how far away they are, then you can plug that number into the equation and get them. And it all depends which way it opens as to which one of these then you're going to use. But so let's update these for just a second. Maybe you don't need these, though, because you can just think about how it got moved and just do that. But let's write them down again. So this is going to be an x squared parabola, so it'd be minus h squared equals p times y. And hk is the vertex. If it opens down, same thing. What's the only difference? Yeah, negative 4p with a y minus k. If it opens to the right, then instead of x being squared, it's y is squared. Now be careful with this, though, because it is still y minus k squared equals 4px minus h. H always goes with the x, k always goes with the y, because look at the coordinates of the vertex. The h is the x, the k is the y coordinate, so we still have to make sure they match that way. Then opening left, then we have y minus k squared equals negative 4p x minus h. Okay, so really it's these four, but then if the vertex happens to be 0, 0, those all simplify down to the original four that I gave you. Let's do one more of this, move on to the completing the squares, because we got through quite a bit of it yesterday, and then just see if you guys can do it. So I'm going to give you an equation, and I want to see if you can sketch a graph of it. Okay, so let's try that. So think about which one of those four up there that's going to be, where that vertex is, and then also include on your graph, because this is going to be a requirement of every one of these you graph, make sure it has the focus, and make sure it has the directrix clearly labeled as well. Okay? So take a few minutes, see if you can figure out where that one is and how it opens and all that business. Anybody need more time with that, or are we okay? Just got something? All right, I'll show you what I got. So this parabola should open to the what? To the right, which means the focus should be to the right of the vertex and the directrix should be to the left of it, right? So, and P is 2, so should look something kind of like that, right? Focus is at 5, 4 then, because the vertex is at 3, 4. And the directrix is back over at x equals 1. And again, make sure those are both clearly labeled too. So I can know that you know exactly where those are supposed to go. So, any questions on that? Feeling okay with that stuff still? It all starts from where the vertex is, right? Where's the vertex? Which way does it open? And then use P to figure out which direction you have to put your focus in your directrix then. So, okay. So let's switch gears here a little bit and take a look at an equation of a parabola written a little bit different. Let's find one here. Here we go. Okay, it's square plus 2 plus 13 equals. Okay, so do you know that that is the equation of parabola just by looking at that? Yeah.
It's quadratic.
Okay, it's quadratic. Okay. And it's got both x and y, but only one of those two is being squared, right? If I had both a y squared and an x squared in there, that wouldn't be a parabola then. It'd be either an ellipse or a hyperbola, actually. But all these equations we've been looking at of parabolas, one of the two variables is being squared, either just the x or just the y, right? So the first thing these questions are going to ask you to do is verify this is the equation of a parabola. Well, right away you can say, okay, well, only y is being squared. There's just a y squared term, no x squared term in there as well. So then I know it's going to be a parabola, and then it's going to ask you, okay, so what is the actual equation of that parabola, written the way that we're used to seeing it, so that we can analyze it. So we can ask questions like, where's the focus? Where's the directrix? Where's the vertex? Which way does it open? All of those kind of questions. We can't really answer any of that stuff until we turn it back into the kind of equations we've been looking at so far. And the way to do that is to complete the square. Okay? So, first things first, I want to get all my y's on one side, all my x's on the other. Okay? So that's going to be my first order of business here. So I guess that would be a minus 13. It tends to be easier if you put it on the side that doesn't have the squared term. So if you got the y's on the left, and that has the y squared in there. If you just don't, because y is the variable being squared here, that's the side I have to complete the square for. Okay? So, think back to, well, we did a little bit of this earlier. Think about how we do that. If I got y squared plus 2y, how do I determine what I need to add to that to complete that square?
Half of the linear term squared.
And what is that then? A 1. Okay. So on that, keep this equation in balance, right? So if I add a 1 to complete the square on the left-hand side, I'm going to have to add a 1 on the right side so that it's still technically the same equation. So in there too. Now the only time you got to be a little extra careful with this is if there's a coefficient in front of y squared. What if I had had like a 4 in front of y squared? What would I have to do first before I could complete the square? Take it out, right? Divide by that 4, factor it out. Then on the inside of the parentheses, complete your square, and then be careful on the other side to make sure it's actually in balance and all of that. This one, though, I didn't. I'm okay. So now that I've completed that then as a perfect square, y squared plus 2y plus 1. Yeah, good. -12. Draft 6. And now I can do all that same analysis I did before. What's the focus? What's the vertex? What's the directrix? Which direction does it open? So let's answer those 4 questions for this then, and we can be done. Okay? So, where's the vertex? 2, -1. Remember, it's always the opposite of both, right? To the right. Where's the focus? Or maybe a good question. Well, no, I won't lead you there. You can do it. What's the focus? Everybody catch that? Why 3.5? Right, it's a 6 in that equation. Remember, that 6 is supposed to be equal to 4p. So p then technically is 1.5. So 1.5 added onto that vertex to the right, right? Because this thing opens to the right, so the focus should be to the right of the vertex. It's going to be 3.5, -1. Yeah, good. To get that directrix, then you'd have to subtract 1.5 from the vertex, move it to the left. Now, if you're a visual person like me, like I can do it like this in my head with no problem because I've been doing this. But if this, the first time you've been looking at this, maybe you need to still draw the thing to see. Okay, it's opening right. P is this, so it's helpful. Please do that. Okay, just because we didn't graph it right here doesn't mean that that's not okay. So, I think it's helpful. By all means, please do that. Because that's about it with everything I want you guys to be able to do with this. So, yeah, got some time to work, right? Let's do it. Okay.